Hello everybody and welcome to the lesson 5 of the School of Solana season 6. This lesson is going to be about best development and also best debugging practices for while you write your Solana programs. This lesson is also going to be presented by Adam, who is also lecturer during the School of Solana course. And yeah, this is basically everything from the introduction. We hope that you are doing great with the tasks that were assigned to you during this cohort. From the numbers, we see that you are really great developers. If you have any additional questions regarding also, for example, the previous lessons, don't hesitate and ask in the dev help on the Discord, and we will try to answer your questions as best as possible. Once again, this is everything, so now, Adam, it's yours.
Hello everyone, and welcome to the next lecture of School of Solana. And today we will be talking about best development practices and debugging. So first I will give you some quick tips, how to keep your code maintainable and how to avoid bugs during the development process. And at the end, we will be doing some hands-on debugging and testing of Anchor programs. So yeah, let's jump in. And the first tip I have for you is modularize your code. So far, during the school, mostly our projects were only in one file, in the lib.rs file, but this is not actually the best approach, so it might be suitable for very small programs, but in most cases you don't want to have such a big spaghetti code. So this is an example of one file of more than 1,200 lines of code with 20 instructions in one file. It really starts quite quickly not being very maintainable. So the advice here is to modularize your code. One example that you can find is in the Anchors repository. So there are actually different examples. There are some basic examples that have only this flat structure. But if you will go in the documentations folder and programs and tic-tac-toe, there you can find a nice example of a structure that is commonly used on Solana in general and with Anchor projects. And I have opened the repository here so we can go quickly through it. So on the left side, you can see the folder structure, which is normal or usual Anchor program. And if we will open the project or the program, you can find here that, as usual, you have the lib.rs file, which is the main source file of your library. And again, as usual, you have here the Anchor's program macro that basically enables you to insert the instructions. But the difference here is that the instructions are here only as wrapper functions for the actual instructions that are in separate files. And one important thing is here that if you want to have some folder structure in Rust, you have to use so-called modules, and you have to publish these modules. So here, the first modules is the errors modules. So here, the modules are actually searched as files in the given folder, or then as subfolders. So here, errors, it is a file, and we can check that in the errors files there is nothing else than the definitions of the errors that we would like to use within our program. And then we have instructions and state. So in instructions folder on the left side, you can see that you have basically separate files for each instruction. So if we will open one instruction, for example, the play, you have here the function play. that is called from the main lib.rs file. And also you have the context here and the context structure. So the advantage here is that you can you have everything that you need at one place, so you can see the business logic of the instruction, and at the same time you can check the constraints that are imposed by the context structure. So maybe we will see it better in the other setup game instruction, because you can see here that, okay, so you have the anchor constraints, so you can directly see, okay, within this instruction we are initializing new account that should be signed by player 1. So these are the instructions, and then we have also the state folder. Again, it's quite practical because usually the states, you have multiple states or data accounts of your program, and this way you have them somehow centralized in one folder. So in this case, there is only one state called game, which is here, and also this file includes different methods that define the actions that you can use on the game structure. So this is a very common way how projects on Solana and also in Anchor are structured. It is quite practical, even for small projects. So in most cases, I would recommend to go at least this way. The next tip is that you should always visualize your program flow and data flow. You will have security lecture later on, so you will again see why this is important. But anyway, it is really good practice to visualize your program flow. On the left side, you can see here who can basically, with some color code, who can invoke the given instruction. So for example, you know directly that admin can invoke only these instructions. So you can also test it, for example, in your tests. And which is also important is really the flow and the sequence of the instructions, because you can directly see here that, for example, you cannot claim tokens before a sale is closed. And this is also very good for testing, to have some visual clue, because then you can directly see that you should test that tokens cannot be claimed before the sales are closed. So this is the program flow, and what is also very good for testing and for documentation for other developers or maybe even users is the data structure. So here you can see an example of an associated token account that basically it is a PDA account that is based on the owner's public key, then the token program ID, and the public key of the mint account. So you can directly see the structure, what is saved where, and how the PDA is calculated. Another tip is to use GitHub workflows and basically the development process tools that GitHub offers. It's quite rare to see projects to use GitHub workflows, but it is actually quite easy. So here we have an example how to set up automatic anchor tests. So here you have a definition of the job that is called run anchor test. It runs on the latest Ubuntu distribution. And first, you just check out your repository. Then you set up, here I have a script that you set up Solana with some specific version. This is just environment variable where you can set the version of Solana that you would like to use. Then you have to set up Anchor, and again with a specific version. And once you have that, you can just execute the Anchor test command. Rust is already installed in the Ubuntu distribution, so that's it. That's all what you have to do. The only thing that is not visible here are the scripts to set up Solana and set up Anchor. These are also not very complicated. I will share a repository after the lecture so you can check it. And yeah, also I think in the Anchors repository they are using also some automated testing, so it's a good practice to check also in other projects how they do stuff. So yeah, so this is very good to set up some actions, for example, on pull requests, that the pull request has to pass some checks. One of them should be that the Anchor tests pass. This is one point, and then of course peer reviews should be done also. So of course, if you are the only developer, then it's not feasible. But if you are multiple persons in your team, then I really recommend that you use that you set up your GitHub in a way that you cannot merge before a second or independent person reviews your pull request, and that the workflow checks or pass. And then another tip on Solana, the difference is, or compared to some other blockchains, is that you cannot control the data that are flowing into your programs and over the transactions that will be sent to your program. So the only way to check it is within your program. So your program is basically public, and anyone can send anything to your programs. So it is very naive to say that. Yeah, very often we hear that some projects say we don't check something in our Solana program because it is checked by our backend. So please don't do that. Every time check your input data within your program, because anyone can call your program, and if you do not check it within your program, then there is a high chance that somebody will exploit it. And then I cannot emphasize it more, but you should also test your programs. You should aim to high test coverage. So often projects that we audit have either very low test coverage or in some cases no tests at all. In most cases the projects test so-called happy path scenarios, so they basically verify that their program works as they would like to work. So for example, we have here the simple ICO, initial coins offering, and some launchpad workflow. So the test maybe cover this workflow, but it does not cover a case where the flow would be different. So again, for example, that somebody would start to buy tokens before the sales are open, or maybe someone would already start to claim the tokens before the sale is closed, or some unexpected scenarios. So actually, the unhappy path scenarios are maybe even more important to test. And so this is one thing. You should really change or test different program flows, but you should also test that you supply or someone supplies unexpected accounts to your program. So if you can see in this diagram that, for example, open sales can be done only by the administrator of the ICO, then you should also test that it is really the case that only a specified admin can test it and not an unauthorized user. And speaking about tests, there are actually different options and a lot of options. So I would say that, the Anchor integration tests using local test validator, this is really a must that every project should have. So this is what you had the chance to see already with Andre, with my colleague during the lectures. And this is also how you test your assignment when you run Anchor test. So this is one option. Another option is also, or like on top option, is to use Rust unit tests. I will show you during the hands-on how you can do it, but Rust has a very nice feature that you can test your methods, for example, and you can write tests directly in your source code. So yeah, it is also a very good way how to test your methods, for example, especially if you calculate or if you do some mathematical operations, it's very good to test it properly using the unit tests. And there are also other alternatives how to test with Rust. So either you can use the runtime, or that basically does not spin the whole local validator. It's I would say faster to run the tests, but maybe some features of the blockchain are not available. Maybe some operations with block slots with blocks and slots are not working as in a real validator. But usually it's quite sufficient also. Or you can use a local validator for the integration tests. There is basically a Rust crate directly from Solana that you can use. And I would say like the last level of testing would be fast testing. Not sure if everybody heard about fast tests, but fast testing is basically an automated way to provide some random inputs to your program, and the fast test is trying really to find unexpected ways and unexpected data that will crash your program. We are developing a Rust-based testing framework that helps you to write tests for Anchor programs. So our tool basically generates a program client that helps you to invoke the instructions of your program, and it also helps you to write fast tests because it creates some it provides a CLI interface to run the fast tests, and it provides some templates. So I will show you during the hands-on how you can do that. And now it's time to pass to the hands-on examples. I have created a GitHub repo for you so you can follow along. And first we will start with this branch 01. But if you would like to jump, for example, in the middle, then you can just check the branches. There are multiple branches, and you can switch to the given branch without having to resolve the previous issues. So as you can see, this is just a normal Anchor program structure as usual. I have a simple program here where there is an initialization instruction, and there is one data account where we can save authorities public key and some counter, which is an unsigned 8-bit integer. And in the initialization context structure, you can see that we have a user, which is the signer, and the user basically signs and pays for the creation of a new data account. And the instruction itself doesn't do anything else than just saving the authority as the user pub key and setting the counter to 0, and then writing the data to the console. And also we have very basic test where we only invoke the initialization instruction. And yeah, and we actually create the user and data key pairs that are passed as accounts into our instruction, and the user signs the transaction. So now if we run the test, we will see if it works. And unfortunately it doesn't. So now you can see the error. It says error signature verification failed. So you might say, okay, so I have here the user, it's within the signers. If we will go back in the program, you can see also that here this is the only signer required by the signer data type. However, if you will find such a failure, then you can be sure that something is wrong with the signers that you provide. So you just have to think if you really supply the correct account that should sign. So in this case, it is correct. But then you have to also think if you really passed all the signers that you are expected to pass. And so actually, in this case, we are creating a new account. It is not a PDA account. If it would be a PDA account, then the program itself can sign. But in this case, you have to also sign the transaction using the key pair of the data account. So if we will do that, we just have to add the data accounts key pair here. And if we will run again the anchor test, then we should see that it works and that this error disappears. And it is the case. So now actually we have different error. Now that we have successfully resolved the first signature failure, we have another problem, and the error said failed to send transaction simulation failed. So if you will see that the transaction simulation failed, it means that the transaction was it was not sent to the validator, and already the simulation failed. And there is some error during the processing of the instruction 0. So yeah, it actually says nothing. So what options do we have how to debug this problem? And I can guarantee that you will have these errors very often, so you must know how to resolve it. One thing, or the very first thing that you should do, is to look in the logs of the local validator. And if you will use Anchor, then one way where to check the logs, if you run the anchor test, then automatically the logs are stored in the hidden .anchor folder under program logs, and your program then has logs corresponding to the pub key of your program. So if we'll open it, you can find here some text streaming transaction logs. But unfortunately, the logs are empty, so it will not really help us in this case. But there is a trick what you can do, one of the options. And the trick is that you can actually skip the so-called pre-flight checks. So here is this RPC method that is sending the transaction to the validator. And there are some options that you can use, and this is the skip pre-flight. If you set it to true, it will skip the pre-flight checks that are done before sending the transaction. So if we will execute now the test again, let's see what happens. So there is still an error, but the error is different. And now we can check the logs. And as you can see, there is already something in the logs. And it is very important to study carefully what is written here. So you can see that status is error processing instruction 0, custom program error 1. This is actually the same that has been written before. But now you can see that there is an error within the program 111. This is the system program that failed. So now you know that the error actually originated from the system program and not from your program, not directly from your program. And also now we are lucky because it is written here that it happened during the transfer, and there are insufficient LAMP ports, and we need actually this amount of LAMP ports. And this is due to the fact that we are initializing new account, and therefore we have to pay for the creation and allocation for the rent of the new account. Now that we know that some of our accounts does not have enough LAMP ports, we just have to find out which one. In this case, it is quite obvious. If we will go to the Solana program or Anchor program, you can see here directly that the payer for this for the initialization of the program is the user account. But in some cases, it might be not so obvious. So what you can do, for example, that you can write into the log the balances. So you can use here the get balance method of the given public key. So in this case, we can run it for the user. If we will run the tests, then it will print the balance to the logs. And if we scroll up, you can indeed see that the user balance is 0. So the only thing that we have to do now is to airdrop some souls. And I have here already a little wrapper function. So one way to airdrop is to use the before hook function that actually executes before the tests, and then you can use the airdrop function. And it is very important also not to forget to await the function. And this is one thing, and I also explicitly set the confirmation here that we want the transaction to be confirmed. That way we are sure that the user will have some balance before invoking the next instruction. So yeah, this function will just airdrop this amount of LAMP ports, and now we should pass the test. So let's try it. And great, so user balance is there, and we have passed the tests. There's also another trick how you could investigate the issue. So let's just delete the airdrop to reproduce the error that we had. And so what you can do is that you could just send the transaction not the Anchor way, but the raw Solana way, let's say. So you could just delete the RPC method here, and you can just get the transaction that you would like to send, and then you can use Solana function send and confirm transaction. And if we will execute the tests now, you will see that the error will change. So now it says failed to send transaction, transaction simulation failed, attempt to debit an account but not found, found no record of a prior credit. So yeah, this is another trick how you can investigate different issues. Now that we have passed our test, we would like to try something else. And let's say that we would like to create and initialize a new data account. So what we will do now is that we will just copy the initialize instruction, and let's let's invoke it once again, and let's run the tests to see what happens. And so, as kind of expected, there is an error. Again, it says transaction simulation failed, and the error is not really user-friendly. It says custom program error 0x0. So we can use the same trick as before. So now it's quite obvious that the problem is in the second instruction. We can again use the skip pre-flight to check the logs. So let's run the tests. And yeah, so now we can see the log. So we can see that the first instruction, the status is okay. The first account was initialized, and the program wrote the expected data in the logs. And then there is a problem in the second invocation of the same instruction, the instruction initialize. Yeah, we can see that there is a problem during an allocation because the address, this address is actually already in use. So you cannot allocate the data account again. And yeah, this is as expected, because if we check in our program, we use here the anchor constraint init. So it shouldn't be possible to reinitialize the same account. So the behavior is as intended. What I would like to show you is, in case you don't have the description of the error here in the logs, it might happen, how you can investigate the issue. So now we can see that actually our program failed because, again, the system program failed. So the program 1.1 and so on failed with custom program error 0x0. So you might ask yourself, what is the 0.0 error? And the way how you have to investigate it is basically to go to the documentation or to the source code first of the system program. So I have here the documentation that is online of the Solana program here, and I'm in the file program error. And here we have enumeration of the program errors, which are indexed from 0. So this is the first error with index 0. This is index 1, and so on. And we can see that the index 0 is the custom error. So it corresponds to our error message. And also here you can see that the second number is the index of the error of the other program that basically, or the custom error that is thrown from some other part of the system program. And if we will go back to our program, it is obvious that the error is during the processing of instruction 0. So it will be an instruction error. And again, you would need to search in the documentation. We can go now, we are in the system program, so it will be the system instruction. If we will go to the system instruction.rs file, here again are another errors specific for the instructions. And if we will check the index 0, that is account already in use. And this is actually the error that we have encountered. So yeah, it's quite tedious, but sometimes it happens that the description is really not obvious or is not there at all. So you have to kind of dive in the code. So this is the way how you can do it. And so now to resolve our issue, we have to go to the tests, and obviously, yeah, the thing is that we are trying to reinitialize the account that we have already initialized, the data account. So again, this is a very simple example. You can see that directly, but if not, then what you can do is that you can, for example, just write in the console the public keys of the accounts that you are using, and then you can compare it with the logs because it says here that this address is already in use. So that way you can connect the public key to the accounts that you are using. Yeah, so to resolve the issue here, what we can do, for example, we will just create another, let's say, data account, data2, and we have to, of course, change it also here in the instruction. And if we run the tests, then we should pass. Yeah, it's green, so we are fine. I've prepared a new example of another bug. So we have exactly the same test code. I have just introduced a small bug in the Solana program. And if we will run the tests, we will see the error message. So now you can see that the error message says already anchor error caused by account data. So in this case, the error is quite self-explanatory because it says also account did not deserialize. So in this case, the error is not in the test script, but it is really in your anchor program. And therefore, we have to go into our program. We will find the data account, and it says that the account was not deserialized. So in this case, it means that probably the space is not calculated correctly. We can check it because now we have 32 bytes, so that corresponds to the public key, and 1 byte to the unsigned 8-bit integer counter. But as you have learned already, we also need to account for the discriminant that are 8 bytes, so we need to add here 8 bytes. The error says that the account cannot be deserialized, which is maybe a little bit counterintuitive, but it's actually because first anchor initializes and creates new account and allocates the given space, and then within your instruction the account is deserialized, and if the space is not sufficient, then anchor actually throws an error during the deserialization. So if we run our test now, we should pass the test. And yeah, the test is green. Now we will do some small modifications to our program. We will actually tell our program that we would like to use a PDA account that will have the seeds for example data, and we also need to send the bump there. So this is how to use a PDA, and we will slightly modify, or we will just delete the second initialization in our program. We don't need it anymore. So if we will run our tests now, let's see what happens. Yeah, so we have an error that says an unknown signer. And so we could actually again write in the console the public keys of the accounts that we are using, but in this case, the unknown signer, it is the data account, and it makes sense because now the data account, it should be a PDA account, and PDA account does not have a private key, so it cannot sign the transaction. So if we will create a new PDA account, it is the program itself that will sign for the creation. So we just need to remove this signer. Let's run the tests again. What happens? And we have another error that says anchor error caused by account data. Okay, so now we know that we are already in our program, and there is some constraint, anchor constraint, that was violated. And if we read further, then we see that the constraint seeds error occurred. Seeds constraint was violated. So it basically means that you are using here the data account, which has address that does not correspond to the PDA derived from the data or from the seed that you have set in your program. So it says that the PDA address does not correspond to this seeds and bump. So what we have to do is we need to calculate the correct address, and this is used for this. We can use public key function. So it's public key find program address sync, and then we need to pass buffer from data. So this is the seed, and then the next parameter is the program ID. So this is program ID. All right, and this function already returns the public key, so you can just delete it here. Oh yeah, and just the square brackets here. All right, so let's check if it works. Cool, and it works. The test is green. To show you the last issue today, we will have to modify our program slightly. So what we are going to do is that we will pass a new count parameter to our instruction, and then we will let's say do some mathematical operation. So we will say, for example, 10. The counter will be equal to 10 minus the count parameter, and then we can do anchor build. It will rebuild the program and generate the IDL, so we can see that in our tests. Yeah, so our test is already complaining, so we just have to pass a parameter here. So for now, let's pass only one and check if the program runs. Yeah, so it works. So what we will try now is we will increase the number that we will pass to 11 and see what happens. And there is an error. It said failed to send transaction simulation failed, and it says program failed to complete. So currently there is no other error code or something like that. So definitely there is an error in our program. We can use our old trick with skip pre-flight to check the logs if there is something more. So let's execute the tests again and open the logs. And now you can see that it says program log panicked at attempt to subtract with overflow. And you can see that, yeah, the system program succeeded. So there is no problem with creation of new accounts or something like that. It is really our program that failed, and you can even see directly the file and the line where the problem is located. So if we will go back, it's on the line 14, and it's obvious here that if we pass count number greater than 10, then we will have an overflow. So To fix that, there are different ways how to fix it. A very common way is to use require macro, so like that, and we can check that the count is smaller or less or equal to 10, and if not, then we will return an error. We don't have a custom error now, so this is something that we can create. When we work with Anchor programs, we can use a macro called error code, and we will just create a new enumeration, let's say my error, that will define our errors. We can also define messages that will be included. So let's say valid count value or something like that, and then the enumeration variant will be invalid count, for example. So this is the error that we will return. So my error invalid count. Okay, so let's try to run the program again, or the tests. Yeah, so there is an error, but if we will open the logs, we can see in the logs directly that anchor error thrown in program at the given location, and you can see that your error code invalid count is in the logs, also with the message invalid count value. And the error number, it's 6,000. Actually, all the custom errors from Anchor are offsetted by 6,000. So your invalid count error has index 0, so that's why it has also the number 6,000. During the introduction, I told you that it is very important to test. So that's why I would like to show you now the different ways how you can test. And we will start with unit testing. So Rust actually supports a very nice way for unit tests, where you can write your tests directly in the source files. One way how you can do that to test your logic is to let's say wrap your functionality in separate functions. So what I'm going to do is that I instead of having this inline calculation of our counter, I will create a new function. So to save some time, I will just copy what I already have. So it will be a function called math function that takes as input the count parameter, and it does essentially the same. It takes 10, unsigned 8 integer, and it subtracts the count parameter. As you can see here, we are using checked arithmetics, so a checked subtraction that returns an option. So in case there is everything is all right, it returns sum and some variant of the option enumeration with the result. And in case of overflow, it returns non-option. And to call this function, we will we'll just call it like that. And as it returns the option type, we would either need to handle the return options, but in this case, because we have already the require condition here, then actually it will never be non-option. So we can just unwrap it. So it's it's redundant here, but it's just for the purpose of this exercise. So once we have this function, we can very easily test it using Rust unit tests. And for that, from the documentation, you can easily copy this snippet. So there is a test configuration macro that tells that this part is related to tests. Then the tests are in a separate module, and you can basically write your tests using additional test macro. And we are also importing the main trait here, the super, sorry, not the trait, but the crate, so that we can use the functions defined in this crate or in this file. And to test our function, you can use we can use the assert macro again. So for example, assert equals, and we can say that, for example, the math function of, and if we will pass 2, it should be equal to 10 minus 2, it's 8. And our function returns the sum option, and the result will be 8. And we can try to test another case where we will pass, for example, 11, where the overflow will happen, and our function should return none. And that's all. What you can then do is just to, for example, here in VS Code automatic code, you can see directly this link, so you can click run tests, and it will run the test that you can see test math function is okay and it passed. And also here you can see the command that has been executed to run the test. So if you just copy this and run it from the terminal, then it will execute the same test. Or also you can just run cargo test like that, and it will automatically execute all the integration tests, Rust integration tests, and also the unit tests. So these are the unit tests, and then now we will extend our integration tests from TypeScript client. So what are we going to do? That we will test also, let's say, for some errors. So we will just copy this test. We will change the name, and we will name it, for example, cannot initialize with incorrect data account. And in the previous issues that I have showed you, was that if we will pass, let's say, some non-PDA account, then we will get an anchor constraint. So this is something that we would like to test, for example. So we will create a new account, just generate a random one. So it is not a PDA as expected. And then now we will pass this account here. And so now we know that Anchor will return an error with the error code constraint seeds, but we would like also to test it. So what you can do, you can wrap your invocation of the instruction to a try catch block, something like that. And then we will catch the error. And Anchor provides a simple parser of the errors we can use. So it's like this, parse, and it actually parses the error from the logs, like that. And then again, we can use we can use assert to assert that we have received the expected error. And also one important thing is that it might happen that in your program you expect to receive an error, but this try and catch block actually will pass correctly if there is no error in your program, and therefore the assert here will never get executed. And if if there is no error in your program, the test will just pass. So this is not what you want. So one thing what you can do is that just after the RPC call, you will add, let's say, a fail call that that this will always fail if it does not fail before. And if it fails here, then it will be catched in your block, but your in the catch block, but your test will not pass because the error code will not be equal to the constraint seeds. All right, so let's try if it works. Okay, it does not work, but yeah, it's because we skipped the pre-flight. And also we have here this parameter that will cause the error in our program. So this is not what we want now. And we will also skip the second test for now. So let's try it again. And yes, it's working. One last thing that I would like to show you is how to verify the on-chain data. So for that, we will use our second test. So we will just delete the skip here. We don't need a console here anymore. Yeah, so when you are testing, it's not enough to only invoke the given instruction and verify that there is no error. You also want to, in most cases, you want to verify that the data written on chain are really the expected data. And what you can do is fetch the given account. So in this case, we would like to fetch the data account that we have stored our data. So, and you can do it like so, that you will await the promise from program account, then it's the my data account, and then you will fetch the data. And here you have to pass the public key, which is the data pub key. Sorry, so it's the PDA. So like that. So this line will just fetch the data from this address and deserialize it based on this account structure. So here you can see the structure from the IDL. And once we have that, we can use assert as before. So assert, if we would like to compare the public keys, for example, then we can use deep equal and then use the data account authority and the authority that was saved on chain should be the user pub key. And then also we would like to verify the value of the counter. So again, we will use assert, then strict equal, and now we will have the data account and the counter. And so now we are passing here 11, which would then return an error. But if we will return 10, then our function in the program should return 0 because it will be 10 minus 10, and it's 0. So also, what might be useful sometimes is to change the commitment here during the RPC call that should wait for the confirmation. So here you can pass commitment confirmed. And that way you are sure that once you await this RPC call, the instruction or the transaction will be confirmed. So if you will read the data later on, the data will be already up to date. So let's try to run our test and check if it passes. And the tests are green. Today we have discussed some best development practices, and I showed you a way and my tips how you can debug your tests and programs. And you can be sure that you will encounter these situations quite often during the development. So do not hesitate to go back to this lecture. However, don't worry, over the time you will find yourself more comfortable to resolve the common issues. We have decided not to give you a task assignment after this lecture, so there will be nothing to submit for the next week. However, my colleague Andre prepared a bonus lecture about SPL tokens, where he will show you a hands-on example how to create a simple program with SPL tokens. And as tokens are also a crucial feature, we would like you to watch this bonus lecture. Not only tokens are used in most Solana programs, but it will also give you more space and more ideas to think about your final project where you might use tokens. So the task for the next week will be to watch this bonus lecture. There will be no grades, and it is voluntary, but I can still highly recommend it. So thank you for today's lecture. I hope that now you will be more confident during the development, and see you next time.